Okay, so I'm Dwan Hall, Senior Manager with Enterprise Product Marketing Team. And as Kate mentioned, I want to talk to you about ATP Cloud and adaptive threat profiling. From an agenda perspective, I want to cover ATP Cloud very briefly and then talk about what is adaptive threat profiling and then continue with a demo of the adaptive threat profiling. So Juniper Advanced Threat Prevention Cloud, ATP Cloud, and I must warn you that my handwriting is encrypted and I have a Maryland public education. ATP Cloud stays on top of advanced threats so that customers don't have to. It provides protection from previously unseen malware, and yes, these are supposed to be eyeballs. So previously unseen malware, as well as advanced threats. Second Tail includes two components. One is Second Tail. So Second Tail, and I told you my handwriting is encrypted. Second Tail is a list of curated threat intelligence curated by Juniper Threat Labs, which Monier will talk about later. In addition to Second Tail, we also have detection technologies and capabilities. And I better stop at detect because I think that Maryland public education is kicking in. The detection capabilities include detection for advanced malware, what we used to call sandboxing, as well as the ability to detect malicious traffic hiding inside of encrypted traffic with something called encrypted traffic insights. ATP Cloud Service becomes the threat intelligence hub for your entire network. Okay, this slide represents everything people hate about PowerPoint. Way too many words, way too much stuff on the PowerPoint. So I'm going to simplify it because this is probably the most important slide for us as defenders when it comes to cybersecurity. This comes from the MITRE Enterprise Attack Framework, and I'm just going to read these first two sentences. It says, attack describes how adversaries penetrate networks, move laterally, escalate privileges, evade defenses, and exfiltrate data. The framework looks at the problem from the perspective of the attacker, identifies the goals they're trying to achieve and what methods they use. Those goals and methods become something we call TTP, or tactics, techniques, and procedures. So if I were to simplify that down for you, it all comes down to behavior. This is the pyramid of pain, first described by David Bianco. And what we're looking at is the pain on behalf of the attacker itself. It's actually quite trivial to change reputational sources. So hashes, IP addresses, domain names. I think someone mentioned earlier, you could spin up 4 million domain names in a single day with this algorithm. Those are very trivial things to change. But eventually, bad actors will take bad actions. So now I want to draw your attention to the NIST incident response framework. This is a very good high-level view of the workflow that we as defenders have to go through. We have a number of protection mechanisms, firewalls, endpoints, et cetera, that live inside of the preparation phase. But those preparation or prevention solutions have to make a very fast decision. I told you my handwriting is encrypted. This was supposed to be a clock. And the reason for that is user experience. No one would wait, seconds, let alone minutes for files to download. Once you bypass prevention solutions, now we're looking at detection and analytics. There are a myriad of solutions from Juniper, some of our partners, as well as competitors focused on detection and analytics. And they either provide enforcement themselves or they partner with a third party to provide some sort of enforcement that's supposed to be stopped. But what I want you to notice is that afterwards, there's always a lessons learned. There's always, a post-mortem, this post-incident activity that informs us and feeds into the preparation phase. So you see this never-ending loop. Well, if we look at cybersecurity from a workflow perspective, this is this cat and mouse game that we've been playing since the dawn of the internet. Now, if I was a talented artist, I would draw you like a really cool mouse and cat and say cat and mouse. But what I want you to focus on is the fact that this is a view of the workflow from both the bad actors here, as well as the defenders here. Again, it's a race with no finish line. Second tail is I mentioned earlier, is curated threat intelligence from Juniper Threat Labs. It enables a threat-aware network. It extends threat detection and enforcement to all points of connection. Obviously, we extended to our next generation firewalls. Yes, we've extended to our Mist APs. In fact, my colleague Crystal Porter-Carrell is going to show you that, but we also support third party as well. Man, my handwriting is really bad. But in addition, we extend security to non-security devices such as routers. Here we can filter traffic at the source, right? We've always been told to block as close to the source as possible. And obviously, we can provide enforcement at our EX or QFX, but we also support third-party devices. In addition to second tail, there are the detection mechanisms that I mentioned earlier. So the ATP Cloud uses machine learning, and I know everyone and their brother is talking about machine learning, but let me describe what I'm talking about here. Machine learning is really a statistical probability. How likely is something to be, benign or malicious? Let me give you a great example. So let's say you're looking out your window and you see me and a buddy walk up to his house. I stare in the window, I climb through, and I let my buddy through the front door. What just happened, right? Well, without context, without additional information, you're unable to determine whether I own that home and I just lock myself out, or if me and my buddy are about to burglarize it. So we give the machine learning model this behavioral data along with statistic data to come up with a classification, is this benign or malicious, as well as a classification for risk assessment. This has to look at both files and traffic in the case of encrypted traffic insights. So now that I've talked about ATP Cloud for a little bit, I wanted to draw our attention to adaptive threat profiling. Adaptive threat profiling is 100% farm-to-table threat intelligence that's unique to your organization. I mentioned that second tail is a list of curated feeds, both from our own research as well as the research of our partners and competitors. But that research comes from, honeypots all over the globe. It's not really unique to you. Adaptive threat profiling gives us context by making threat intelligence that's unique to your organization. If you sat through a number of Juniper presentations, you've likely heard AI-driven enterprise or AI ops or machine learning. You'll notice I touched on machine learning very, very lightly. But AI ops or AI-driven enterprise is not the North Star for Juniper. The North Star for Juniper is user experience. The AI ops and machine learning is just a means to the end. And when we're talking about adaptive threat profiling, we're talking about the user experience of the security practitioner, the SecOps folks. And adaptive threat profiling is not your typical alert fatigue discussion, although I'm going to save this slide for the next time I'm having the alert fatigue discussion. The point of this slide is to show you that threat intelligence, it does not necessarily equal threat information, does not necessarily equal threat intelligence. And I know it's a little hard to see. Maybe I should draw that in the street. In order to be intelligence, it needs to be actionable. When we give you a feed that's curated, we expect customers to be able to take action off of this threat intelligence. And for that, you need to have context and validation. But don't believe me, right? Like Ronald Reagan said, trust but verify. And when you work with a lot of writers like I do, the definition words mean a lot. So threat intelligence, according to Gartner, is evidence-based knowledge, including context, there's that word again, mechanisms, indicators, implications, and action-based oriented advice about an existing or emerging menace or hazard. I'm not going to read the whole slide, but I did want to include this one. The intelligence can be used to inform decisions. And that's what we're talking about with adaptive threat profiling. So again, it's 100% organic. It's farm-to-table threat intelligence unique to your organization. It converts the SRXs into sensors. They can be deployed inline in protection mode, or they can be deployed alongside of competitive gear in a passive or tap-like mode. And it's acting as a sensor looking for customer-defined behavior. So if a detection has occurred, we take the offending IP address, we share it with, and this should say ATP Cloud. We share it with the ATP Cloud, and then all other devices subscribe to that realm inherit that threat intelligence feed. These feeds can be used in security policies as part of dynamic address groups. They can also be added to the infected host feed. So the infected host feed, that comes down to host remediation and allows you to either block or quarantine. And today, we can do detections from standard layer 4 policies. Unified policies is a Juniper term, but what we mean are layer 7 policies, or NGFW, right? It's the application and or the URL category is a match criteria for the security policies, as well as IDP. And obviously IDP is also a layer 7 technology. Okay, adaptive threat profiling 101. Very first thing is to determine your use case. I cannot overemphasize this enough. You do need to be clear in your thinking, right? So determine the use case that you're trying to address. Once you do that, create a feed in the ATP Cloud dedicated to the use case. And then third, create a policy that will generate detection events related to that use case. Okay, let's talk demo. So first, I want to call out that this is a tactic ID, T1571. This is a risky user use case. This is a threat intelligence local to this organization. I have a Secure Connect client, which is our remote access VPN. We're all working remotely. And what you're going to see me do is connect to the SRX and VSRX in AWS. I'm going to connect to a business app on port 80, the standard page, pen right here, right? And then I'm going to do a suspicious activity where I'm going to connect to a bad site, and I'm going to use an alternate port. It's going to be :8888, right? And my objective, or what I'm trying to do, is establish a command and control. The technique is use HTTP or SSL on a non-standard port. So let's take a look first. Let me, so what you're going to see me do, I'll fast forward a little bit. First, I'm just showing you that there were no IPs in the risky user. When my VPN connects, I'll bring it up. So now I have 5 addresses. At this time, I had 2. And then I connect to the VPN. So this is me showing the route. All right, connect to the VPN. And then you see here's a new address, 199.254.71. All right. And then I'll actually show you the policies live, but let me just jump forward real quick. I'm showing you the policies. I'll talk to you that live. I'm just going to jump over and show you what I did. So I connected to bizapp.acme.com. So this is my business critical app. And then I also made a connection over to a site called safe.trusted.com on port 888. And this was my command and control. Okay. So when I did that, if I look at the security policies on the SRX, I have a security policy here that says suspicious. So if anybody connects on HTTP or SSL, these are the dynamic applications, using a non-standard port, notice that my policy says to add the source IP to the risky users ATP group. Then the next policy allows anything. You see, the first policy leverages that risky users ATP address group as a source address, and then I add additional security capabilities. So I've turned on IPS, I've turned on UTM, SSL forward proxy, which is decrypting SSL traffic, as well as advanced threat protection policies. So here, rather than blocking the user, I added additional inspections, which can be used to provide context, as well as potentially collect some indications of compromise. So let me go back to here with my video. I'll just quickly show you. Let's quickly show you that there was a 3-minute delay for the propagation. Slide down, and then we're going to see, okay, that my address was added to the infected host feed. Let me jump back to PowerPoint. Here, I'm just calling out that these are a number of advanced threat actors that have used this technique and procedure T1571 for command and control. But again, without the context, we don't know whether this was just a web server running on an alternate port or if this is truly command and control. So rather than blocking the user, we look to get additional context. I think when I'm talking to customers, any customers has ever read the Google Corp doc, they always say, well, I don't want to block the host. I want to add additional inspections. And as you saw, that's exactly what we did with this adaptive threat profiling. So you may be saying to yourself, well, we can kind of do that today. And you're right. But with the typical approach, what you need is some sort of external scripting or tooling or whatever have you. So here you would have like the SRX does some detection. It sends a log to something. It could be a SIM like our JSA, a SOAR, or XDR, or Security Director Insights like we're going to see later with Medora. But something has to receive the logs, it has to normalize it, run the logs against some sort of policy or rule matching engine, and then do something. That do something might be, flag down a human being, or might be run this Ansible playbook, or run this Python script. The point is that it does something. With adaptive threat profiling, we don't need an external workflow to achieve the same result, right? Rather than detection and just send log, it's detection, send log, and do update a feed. So this is a workflow view. This is the nerd view. So I'm a nerd. I've come to terms with that over the years. I've had the privilege of running the hackathon for Juniper's Nextwork customer events in 2018 and 2019 when we were still meeting in person. And in 2018, we did a workflow trying to show security automation and integration with third parties. So what I had was an SRX sending IDP events to an event-driven infrastructure. This was actually SaltStack. It would send it to the message bus, and then SaltStack would monitor the message bus, and then it would, take the source address of that event and then update the config on the SRX. And then in 2019, we took it a step further where we were using our JSA Juniper Secure Analytics, which is our SIM. I would have the SRX send logs over to the SIM. The SIM had a rule that says, if you meet these conditions, add the address to a reference set. And then I had a separate script that would make an API call, and it would grab that information from the reference set, shove it into a custom feed, and then eventually our security director and policy enforcer would download that feed. All of that workflow has been eliminated with the adaptive threat profiling. This is making it easier on the security practitioners. So with adaptive threat profiling, again, all the devices subscribe to ATP Cloud, and within that realm, now have a federated policy with, again, farm to table, 100% organic threat intelligence that's unique to your organization.
But so the threat intel that you're getting through the threat profiling, is that coupled with the SEC intel that you guys are getting from yourselves and your partners? Say, when we're detecting a threat in a user's network, does the user have the ability to say, if an indicator of compromise matches anything from SEC intel, go ahead and block it automatically? Is there any conversation between the two, SEC intel and the user's threat profile?
Okay, great question, Corey. So adaptive threat profiling is a type of feed. It's a custom feed that is available within SecIntel. So you need to have a SecIntel or ATP Cloud subscription to take advantage of it, right? So then you can consume the SecIntel feeds as well as this adaptive threat profiling feed. What you do with that feed is up to you. You could actually block. So I could say suspicious users, anyone doing a network scan, add them to the blocked users, and now they're blocked at the firewall with like a traditional layer 4 policy. I don't want to do, and there's no need to do app ID inspection for something I want to block. So I could absolutely do that. Or I could do like I did was, so I'm going to add additional inspections. I don't want to block, I want to get additional context. Hopefully that answered your question. Is that good?
Yes, it does. So just a follow-up question then, sorry. Is a user able to write rules like directly related to the SecIntel information? So say if if this matches anything from SecIntel, block it automatically, or does that have
Yes.
has to be done on a case-by-case basis?
No, yes, you can take the SecIntel. The information is meant to be actionable. It is curated, and yes, you can absolutely take action within a security policy on information from SecIntel.
Is the security intelligence unique to each customer, or do you basically anonymize the data from customer A through Z, put that together, then feed that out to all of the other customers?
Okay, so adaptive threat profiling is unique to the customer implementing implementing adaptive threat profiling. Information that is shared or curated by Juniper Threat Labs, I'm actually going to defer to Munir Hahad as far as how information gets exchanged into the master SecIntel feed, because they can't just we get a lot of information, but they have to curate it and then provide it to our customers. But the adaptive threat profiling is unique to the organization, and I'm not sure what the transition between the two would look like. So I would have to defer to Munir for that one.
Okay.
I have also an additional question. How large can you scale when it comes to IP or DNS entries in these lists?
And the adaptive threat profiling feed, I believe, is 10,000 entries, but we have Crystal Portocarrero with the PLM, and she could actually get a definitive answer on that for you. But 10,000 custom feeds from adaptive threat profiling is a number that is stuck in my head.
Okay. And while we're talking questions, we've got a question from the Twitters. Gentleman from Germany is asking, it's really cool technology, but he's fearing that in Germany it won't be legal, and he was wondering if the ATP engine can be hosted on premises.
ATP cannot be hosted on premise. However, we have multiple ATP Cloud regions for data privacy concerns and regulations, and there is no cross information between ATP Cloud regions. So a region in EMEA, for example, does not share information with the US, if you will. And so what you could have is a customer who's subscribed in Germany with a Germany realm, and all the devices within that realm can get that feed. And then if they have, as an international company, they can provide additional threat intelligence from a different realm. Hopefully that answered the question.
Okay, thank you.
Absolutely. Thanks for interrupting and asking questions. So
you're almost done. I have one more.
Oh, please. It's your meeting. It's your time. Make it yours. What do you got for me?
I'm sorry, John. It'll be quick. So at what frequency are you guys scanning for new threat intelligence? Is this constant, or is it on a set basis?
So there's that question is more related, I think, to the SecIntel piece. And I would invite you to ask that very question to Munir in his section. The adaptive threat profiling is real time as far as the detection. There is a timer, I want to say it's every 5 minutes, as far as uploading or pulling the adaptive threat profiling feed.
Okay, awesome. Yep. Thank you.
Okay. So far I talked about threat use cases, and that's kind of one that we typically like to look at, but there are also classification use cases. Suppose I want to deploy IP cameras and I knew some traffic pattern unique to my camera. I can create a policy that does a detection, automatically add the cameras to that feed, and every firewall within my organization subscribed to that realm could be updated. Or maybe it's not cameras. Maybe you want to know about all the Ubuntu servers or all the Windows Server 2016. Right? There are a number of different classification use cases available. In fact, the use cases is pretty much unlimited. We've put forth a number of use cases of both threat and classification for customers to sort of give them ideas of what's possible with the technology, but we fully expect the customer, and in fact invite customers to come to us with additional use cases that we can share with the community at large.
So in ATP, you talked about customer-defined threats. Are there templates for customers to pull in to sort of to make the definition process easier, or is it all customer defined?
That's a little bit of a loose question. So what I meant with when I said that was with the ATP adaptive threat profiling, excuse me. It's hard when you have two ATPs there. So adaptive threat profiling is based on customer defined detections. So we do have templates. So let's say you wanted to use an IDP template and take the recommended. Let's say we take the recommended enterprise recommended IDP template, and we want to do blocking or whatever have you. But now I also want to add you to a new risky user. And this IDP policy has packet capture turned on in addition to blocking. So that's something that's available. So there are templates. There are over 4,000 applications that you can match off of. So it's pretty much, unlimited use cases there.
Great, thank you.
Absolutely.
So this is coming from the angle of targeted attacks, yeah? So how do you protect the list? So I have the feeling I have many devices. So let's say I have 100 SRX firewalls. They are all subscribing to that feed. How do you protect the feed that really only authorized entities can receive that list, so that let's say attacker cannot easily pick up that I detected his threat? Yeah.
Great question. Okay. So when I said all devices subscribe to the realm, this means the device must be enrolled. When the device is enrolled, there's some validation that happens with the serial number, with the licensing, etc. And then the connection between devices enrolled and the ATP Cloud is a secure connection. So it's over the control plane or out of band, if you will. It has a secure SSL certificate that's installed as part of the enrollment process. And so you validate and authenticate both the client and the server in that transaction to download this feed manifest.
So you encrypt in transport and you encrypt in REST when it is in the cloud saved, yeah?
That I'll refer to Monir as far as if it's encrypted within the cloud, because I actually don't know the backends workings of the cloud. Having said that, we are subject to a number of different regulations. So I imagine I could give you a qualified yes. But yes, the traffic between ATP Cloud and the SRX is absolutely protected within the TLS session.
Hey, one last question then, if I may.
How,
when you're deploying this, what's an average customer take? I mean, what does it take for someone to deploy this technology? How many people, how many resources? What kind of monitoring would they do? What are we committing to when we do this?
That's great. So a typical deployment would come first, whether or not they understand the interface of the SRX. Let me get out of this PowerPoint mode if I can. I'll discard those changes. So this is what the configuration looks like. If they can create a security policy within the JWeb, which is quite trivial, literally come in, my new policy, right, and just fill out the form, right? So from the VPN, a specific address, I'll use that risky user. I don't see them in there, but that's okay. I'll grab this address from this source, okay, and create. Basically, I won't fill out the whole thing, but basically fill this out and then add an action that looks like at the end the action is add a source. So if the user can create a security policy, and I need to go tab over here, they can come in to adapt the threat and say, my new feed. Oh, I don't know what happened to my screen there. I think I got logged out. It's okay, folks. I'm a professional. And I can type my password, honest. If you can go in and click a new feed within the ATP Cloud. So this is the ATP Cloud interface. Configure adaptive threat profiling. All right. New feed. Now, all I need to do is create my SRX. Did I give it a new name or something? 2 new feeds. So now this new feed is available, and all the SRXs subscribe to this realm. For instance, and here, when I say that, these are all the devices that are subscribed to my realm. They all have access to that feed at the next second tail update cycle. The big thing is the one I mentioned earlier in the PowerPoint is just getting clear in your thinking. I think like anything else in security, technology is just like the tool. It's the policy and everything else that you kind of need to get really clear in your thinking on.
An intermediate question, how often do you update normally on default these feeds?
Okay, the adaptive threat profiling is on a timer. I believe the timer is 5 minutes as far as uploading, downloading. Each of the other feeds have different timers that are dependent. And as far as how often are our second tail feeds being updated, that's continuous. I mean, that's what our Juniper Threat Labs, that's what they do, part of what they do.